Modern agriculture is undergoing a transformation unlike any it has seen before. The fields once tilled by hand and plowed by draft animals or the earliest motorized tractors are now vibrant test beds for technology. Today's agriculture machines are not just tools, they are intelligent partners that operate with breathtaking precision, power, and autonomy. As we look across the landscape of 2025, it becomes clear the machinery driving global agriculture has reached an entirely new level. The past year alone has seen remarkable breakthroughs that are redefining farming's possibilities. Perhaps the most headline-grabbing advancement is the arrival of truly autonomous tractors. In January 2025, Deere & Co., a name synonymous with agricultural innovation, unveiled its latest suite of autonomous tractors and industrial machines at the CES trade show. These vehicles, equipped with advanced computer vision and artificial intelligence, have shattered the boundaries of what was once thought possible. Imagine a tractor with no one in the cab, navigating vast fields with centimeter-level accuracy, making real-time decisions on soil conditions, crop health, and obstacle avoidance, all without direct human intervention. This is no longer science fiction. Deere's autonomous fleet is designed to address two of farming's most pressing challenges: persistent labor shortages and soaring operational costs. With the ability to work around the clock and across all weather conditions, these machines are poised to transform not just productivity, but also the economics of agriculture itself. But autonomy is only the beginning. The push toward sustainability has spurred a revolution in power sources as well. The shift from diesel to electric and hybrid machinery is accelerating, marking a decisive move toward greener, quieter, and more cost-effective farming. Companies like Solectrac and Mahindra are leading the charge. Solectrac, for example, reported a staggering 30% growth in 2023, fueled by the adoption of its electric tractors across North America. Meanwhile, Mahindra's e-Kali electric tractor has seen over 10,000 units sold within just 6 months of its launch, a surge driven in part by supportive government subsidies. These electric and hybrid tractors are more than just environmentally friendly. They are engineered for resilience and efficiency. With fewer moving parts than their diesel counterparts, maintenance costs are slashed, and downtime is minimized. For farmers, this means more reliable operation and lower total cost of ownership. The benefits go beyond the bottom line. Electric machines operate with near silence, making them ideal for use in and around communities and reducing the overall carbon footprint of food production. Precision agriculture is another area where technology is elevating farm machinery to extraordinary heights. The integration of sensors, artificial intelligence, and the Internet of Things has given rise to a new generation of smart implements. Drones, once used primarily for aerial imagery, are now central to crop monitoring, soil health analysis, and targeted chemical application. AI-powered drones can scan entire fields in minutes, identifying stress, disease, and pest outbreaks long before they become visible to the naked eye. One of the most impressive new tools is the Smart Sprayer. John Deere's See & Spray Ultimate is a leading example. Utilizing a combination of machine vision and AI, this sprayer distinguishes between crops and weeds in real time, targeting only the unwanted plants with herbicide. The result? A reduction of herbicide use by up to 50%, slashing input costs and minimizing environmental impact. For farmers, this is not just about saving money, it's about advancing sustainable agriculture by reducing runoff and chemical exposure. Robotics are also playing an increasingly vital role. In orchards and vineyards, labor shortages and the physically demanding nature of pruning have long been obstacles. Now, autonomous robotic pruning systems are stepping in. These machines, equipped with sophisticated machine vision systems, navigate rows of trees and vines, assessing branch structure, and making precise cuts. This automation not only addresses the difficulty of finding skilled labor, but also increases the consistency and quality of pruning, essential for optimizing fruit production and plant health. Of course, these technological leaps come against a backdrop of economic uncertainty. In November 2024, Deere & Co. forecasted lower than expected profits for 2025, citing decreased demand for farm equipment. The culprit? Declining farm incomes and inflationary pressures that have made capital expenditures more challenging for producers. Yet, even amid these headwinds, the momentum behind innovation has not slowed. If anything, the need for efficiency and cost savings is driving even greater adoption of advanced machinery as farmers seek to do more with less. The convergence of artificial intelligence, robotics, electrification, and precision technology is shaping a new era in agriculture. Let's delve deeper into how these elements are coming together to create machines that are truly at another level. Autonomous tractors are perhaps the most visible symbol of this revolution. Unlike their predecessors, which relied on GPS-guided steering and required an operator in the cab, the latest generation is fully driverless. These tractors are equipped with an array of high-definition cameras, radar, and LiDAR sensors, creating a digital map of their environment in real time. Sophisticated AI algorithms process this data, enabling the tractor to make split-second decisions, adjusting speed, steering around obstacles, and optimizing routes for maximum efficiency. The implications for farm management are profound. Operators can monitor and control these machines remotely, often from a smartphone or tablet. Fleet management software allows for real-time tracking of productivity, fuel or battery use, and maintenance needs. This data-driven approach means that farms can operate with unprecedented precision and agility, responding to changing conditions as they happen. Electrification is not just about tractors either. Electric harvesters, planters, and even irrigation systems are becoming more common. These machines are often paired with on-farm renewable energy sources, such as solar panels and wind turbines, allowing for closed-loop, sustainable operations. The ability to store and use electricity on site further insulates farmers from volatile fuel markets and reduces reliance on external power sources. Precision agriculture leverages a suite of interconnected technologies. Soil sensors, for instance, provide real-time data on moisture, temperature, and nutrient levels, enabling variable rate irrigation and fertilization. Rather than treating a field as a uniform block, farmers can now tailor inputs to the specific needs of each plant or section. This level of customization improves yields, reduces waste, and minimizes environmental impact. Drones have become indispensable tools in this ecosystem. Outfitted with multispectral cameras, they can assess crop health, detect pest infestations, and even estimate yields before harvest. Some drones are equipped for direct action, dispensing targeted doses of fertilizer, pesticides, or biological controls. Their ability to quickly and cost-effectively cover large areas makes them ideal for both small farms and vast commercial operations. Robotic systems are expanding beyond tractors and sprayers. In horticulture, autonomous harvesters can identify, pick, and sort fruits and vegetables with remarkable dexterity. Machine vision and AI enable these robots to assess ripeness, avoid damaging produce, and work alongside human teams for maximum efficiency. In livestock management, robotic feeders and milking systems ensure consistent care and monitoring, freeing up time for farmers to focus on higher-level tasks. The integration of all these systems is facilitated by the Internet of Things. Sensors embedded in equipment, crops, and soil continuously transmit data to centralized platforms. Here, powerful analytics software turns this torrent of information into actionable insights, predicting equipment failures, optimizing planting schedules, and even forecasting market trends. By connecting every aspect of the farm, these platforms enable holistic decision-making and continuous improvement. Yet, despite these technological marvels, challenges remain. The initial cost of adopting advanced machinery can be high, particularly for small and medium-sized farms. Training and technical support are essential to ensure that operators can make full use of new systems. There are also concerns about data privacy and cybersecurity, as farms become increasingly reliant on connected devices. Still, the benefits are undeniable. Modern machines reduce the physical toll of farm work, enhance safety, and open new opportunities for young people and those with technical skills to join the agricultural workforce. They also support the global imperative for sustainability, using fewer resources, emitting less pollution, and producing more food on less land. Looking ahead, the trajectory of innovation shows no signs of slowing. Research is underway to develop even more advanced autonomous systems capable of handling complex tasks like selective harvesting and real-time disease diagnostics. Battery technology continues to improve, promising longer runtimes and faster charging for electric equipment. AI models are becoming ever more sophisticated, able to interpret subtle cues from plants and soils that once eluded even experienced farmers. Government policy and industry collaboration are playing pivotal roles too. Subsidies and incentives are helping to offset the costs of adopting green technologies, while partnerships between manufacturers, universities, and startups are accelerating the pace of discovery and deployment. In the end, the story of modern agriculture machines is not just about metal and circuits. It is about empowering farmers to feed a growing world, steward the land, and adapt to a rapidly changing environment. It is a story of resilience, ingenuity, and hope, written not just in lines of code and blueprints, but in the fields and communities that depend on them. As we stand on the threshold of a new era, one thing is clear. The machines of today are truly at another level. They represent not just the future of farming, but the future of how we produce, protect, and sustain life itself on this planet. The fields are changing, the machines are evolving, and the possibilities are endless.